We are doing a second part of Unit 2B notes here. This one is going to be looking at types of triangles and how we can use the different relationships in some of these types of triangles to help us do some problem solving and working our way through assumptions again. So we have these types of triangles here. There's four generally types of triangles. We have scaling, right, isosceles, and equilateral. What's not listed here is acute or obtuse. Acute is when you have all the angles less than 90, and obtuse is when there's an angle greater than 90. So when we click on this interactive, let's take a moment and look at that. So see this red one in its current state, it has an angle bigger than 90. That means it would be obtuse. But if I drag it up, now it's acute because all three of these angles are less than 90 degrees. All right, but now let's take a look at this and kind of see what happens with this. So on a scaling triangle, all sides and angles are unique. That's always true. Does it have a right angle? It could, it's possible to be a right triangle, like if I were to drag B or A or C into a specific location, but it's not always that way. Has two equal angles. If it's scaling, all the sides and angles have to be unique, so that can't be true. Has three equal angles. That can't be true either. Has an obtuse angle. Sometimes true, like I showed that it could be obtuse, it could be acute. All right, now let's take a look at the right triangle. So when I move around this right triangle, no matter where I move these points, that right angle is always there. It is possible for me to kind of get close to making two equal angles. Let's see if I can get it close here. Oh, it's really hard to get it exact. It's hard. It's so hard to get that exact. But really, if it was 45, 45, then those would be split exactly, and these two numbers would also be split. So a right triangle, all sides and angles unique. Well, sometimes, because I can make those two angles 45, and then those two sides would also match as well. Has a right angle always. It's a right triangle. Right triangles always have a right angle. Has two equal angles. Sometimes. So that kind of goes along with the sometimes here. Sometimes they're unique and sometimes they're equal. Has three equal angles. That's impossible. And you'll see kind of why. But if one of the angles is 90, you can't have all three angles 90. That would be too big because it maxes out at 180 for the three angles inside. Has an obtuse angle. That's also never going to be true because the 90-degree angle is going to be the largest one. In order to add up to 180, the other two angles can't be bigger than 90. It would be too big, too much angle on the inside. All right, now let's look at isosceles. And what do isosceles triangles do? Well, so for this one, I noticed that as I move this triangle around, it has this symmetry to it, where these two angles are always the same and these two sides are always the same. So no matter how I move this around, it's got that interesting symmetry to it. Okay, so that means will it have all sides and angles unique? No, it won't, because you're going to have matching pairs. Will it have a right angle? It's possible. It is possible. So let's see if I can get this to get close to a right angle. So it's hard to be precise, but I could lock that in at a 90, 45, 45. And that is possible. So sometimes. Has two equal angles. It sure does. It always does. Has three equal angles. Okay, this is interesting now. Could I make it so that the three angles are equal? And it is possible if I start moving this closer and closer and closer. So if it's isosceles, but they happen to be 60 and 60 for the matching pairs, it's going to force that third one to also be 60. So that's a sometimes. Has an obtuse angle. Sometimes. That third angle, that we call this the vertex angle, could be more than 90. I can't get these bottom ones to be more than 90, but I can get that top one to be more than 90. All right, equilateral. Equilateral is what we say is the triangle where everything's the same. All the angles are the same. All the sides are the same. So we usually hear the term equilateral more commonly, but it could also be referred to as equiangular. So equiangular means equal angles. Equilateral means equal lattices or equal sides. Okay, so equilateral. All sides and angles unique. Never, because they're all the same. Has a right angle. Actually, it can't because the angle locks in at 60 degrees all the way around. Has two equal angles, always. It actually has three, but technically that means at least two of them. And has three equal angles, always. Has an obtuse angle, never. All right. So those are kind of the properties that we're looking at. But now let's talk about like how we can use that and how that relates to doing some problem solving, some algebra for finding unknown sides. So these are all drawings. So I'm going to click in them and then edit. And what I notice here is that I can take a line like this, which is awesome, and that splits it in half. So I'm going to make that actually a dashed line there. So that kind of splits it in half, which means that both of these sides are equal, which means that 7 is the same as 2x minus 11. So I'm going to put myself back into a side-by-side where I can do some more equation solving. And here I will have 2x minus 11 is equal to the other side, which is 7. That's awesome. Now I can just solve this equation. Add 11 to make a 0. And that gives me 2x equals 18. Divide by 2. And that's going to give me x equals 9. So all I'm doing is solving for x, and I did that. Nice and quick. Capture it, copy, paste it. I'll make it a little bit smaller to fit in there. Now let's look at this one. Ooh, this one's a little bit interesting, so let's do some editing. Here's what I suggest you kind of do with this on these isosceles triangles where some things are marked but some things are not marked. Is you're going to take a picture of the piece that you can want to duplicate. So I look at this 40 degrees here, and I can copy it to my clipboard and then paste it. And I know that this other side is 40 because it splits down the middle and it folds in half, meaning that both of those are equal to 40. There, it has the symmetry. It kind of has a fold in half where both sides are equal. So I got 40, 40, and x. Those three angles add up to 180. So I can say 40 plus 40 equals, plus x, pardon me, the three angles add up to 180. Now, you can almost do this mental math here. It's going to come out to 100, I believe. So if I add the 80 there, the negative, make a 0, and then I'm going to say x equals 100. Awesome. So use that ability to kind of duplicate things to show where there's stuff that shows up in more than one place. Ooh, this one's like almost just, we're just going to call this mental math because I have two sides. I will draw the symmetry line, like there is a symmetry line down the middle here. And that means that, whoops, let's take those back. So there's a symmetry line kind of down this middle, which means that 60 and x are both equal. So I could just say x equals 60, just like that. For some reason, the picture didn't update, but that's okay. Hey, another one, very same idea. Excuse me. Oh, it looks like we're just losing a little bit of connection, but there's a line of symmetry down the middle here, which means that x equals 46. Sometimes they're that short and sweet because you're just noticing, oh, those are equal on both sides. All right, let's take a look at this one because this one has a few things going on. I noticed that there's 134 there, and I notice that I have an x here. I could say 134, 180 minus 134. And that's going to give me 46. I'll just copy and paste this. I don't even have to like insert a text box. I can just copy and paste this 46 right into this picture. So that is 46 because those two angles add up to 180. Now let's do another kind of copy and paste of an angle measure, this x. Because this is an isosceles triangle, that side is x, but so is, whoops, let's try that again. I copied it, but I forgot to paste it. Paste it in here. Oh, maybe I did paste it there, but it's up there. Nope, there it is. So x and 46. Now I have three angles inside a triangle. And those three angles are going to be x plus 46 equals 180. So I could subtract 46 from both sides, and I can also combine these x's. So I got 2x equals 134. I'm going to divide by 2, and that gives me x equals 67. Awesome, awesome, awesome. Paste this in here. That'll work. Okay, now as we go through the rest of these, sometimes, these I'm supposed to try and figure out what angle 2 equals. So I'm trying to find the measure of angle 2. So I'm going to just work this one out here. I have 37 and 37, so I could copy and paste that 37. I'm going to paste it right back on top of it because it goes over here. There's a symmetry between those two things. And then I notice that 37 and angle 2 is going to make 180. So just a simple calculation, 180 minus 37. That's a real basic calculation. It's 143. That's my total work for this one. Just kind of a little bit of reasoning in the drawing, and then a little bit of numerical calculation for the other piece. That's extra large. Doesn't need to be that large. All right, let's do another one. We see that this is 60, this is 60, but here's the interesting piece to this picture. I notice that I have 60, and I'm going to paste it here, but if it's a 60-60 triangle, it's going to be 60-60-60. So measure of angle 2 is also equal to 60. So I could say 9x plus 6 equals 60. And now I could solve this equation. I could subtract 6 from both sides and figure out that divide 9 by both sides, and then that gives me x equals 6. So either solving for x or solving for angle 2. Angle 2 was equal to 60, but if it needed me to solve for x, I also have that. All right, we're going to do one more, and then we'll leave the rest kind of for you guys to work through if you want. This will be our last one. I notice that I have 92 here. But I also notice that I have this 3x plus 14 is in there for the angle 2. So I'm going to capture that, paste it, and that means that angle is 3x plus 14. And so is that angle. So I have 3x plus 14, 3x plus 14, and 92. Those three together make a triangle. So 3x plus 14 plus 3x plus 14 plus 92 equals 180. So that's the setup for the equation. Then you just have a lot of combined like terms. I can combine the 14 with the 14. can combine those two constants. I could combine those two variable terms. Now I could subtract 120 from both sides. And I get, in the end, if I divide by 6, x equals 10. So that's a lot of terms, but the idea is still the same. 3 angles add up to 180 inside a triangle. And we'll call that the end of the video, especially with that being the bell that just rung.